Vb cos alpha will be equal to V sin alpha, because Vb cos alpha is the velocity with which B is approaching A, and V sin alpha is the velocity with which A is receding B. So if they are equal, then the velocity of approach of these two would be 0. And based on the merit of the discussion we had before, when the velocity of approach is 0, then that is the point at which we have the distance of closest approach. So if you are looking at the distance of closest approach of A and B, that is the minimum distance between A and B, then this should be the condition. The velocity of approach should be 0. Now from here we have tan alpha is equal to Vb by Va. Vb is 15, Va is 20. So this is 3 by 4. Okay, now in this triangle, if we find tan alpha is perpendicular. This is perpendicular upon base. Now this length, A has traveled from here and gone all the way to here. This would be at any time t, the distance would be 20 into t, because the speed of A is 20. So this whole distance is 20 into t, and this is 500, it was given. So this rest of the distance should be 20 into t upon 500. So tan alpha would be equal to perpendicular, which would be 20 into t minus 500 upon base. Base would be the whole distance is 400, distance traveled will be 15t. So this base of the triangle should be 400 minus 15t. Now this tan alpha already we have calculated as 3 by 4. So we just have to equate it with 3 by 4, and we have to find t from here. The t that we will get from here would be 128 by 5, and then we put t here and we find this distance. We find this distance using Pythagoras. We find this distance, and this distance is the distance of closest approach between A and B. That's what we do. So you find t from here and then put t, and you find the distance of closest approach. And then you take a piece of paper and you work through this problem one more time using all the 3 methods we have discussed. Think about each of them, spend some time with it, and you yourself figure out which one is the easiest for you. This concept we will study again when we study collision in the next to next chapter. We will study the concept of velocity of approach and the distance of closest approach. This was just an introduction. This is actually a preparation for you to study that chapter. But whatever we have studied here should be clear here itself. So you solve this problem one more time using all the 3 methods we have done. Okay, so similar to this problem, let's solve one more one so that you get handy with this kind of thing. There are two trucks, suppose, at point A and B. The distance between A and B is 10 km. Truck at B goes straight along this line with a speed of 20 km per hour, and the truck at the truck at A, it goes towards west straight with constant speed of 20 km per hour. Now you have to find what is the minimum distance between the truck at A and truck at B during their course of journey. Try and use the concept of velocity of approach in this problem, like we have done in the third method of the previous problem. Okay, let's see how we will go about doing it. Suppose at the intermediate stage of the journey, the truck at A has reached at this point, and the truck at B has reached at this point. And this is a general angle alpha. Let's try and write the velocity of approach at this moment. Now the velocity of the truck at B would be 20, which is constant. So along this line joining A and B, the velocity of B along this line would be 20 cos alpha along this direction, and that of A would be, if this is alpha, this is 90 minus alpha, This is 90 minus alpha. Velocity of A would be 20 cos 90 minus alpha. That is 20 sin alpha. Now A is going towards, B is going towards A, and A is receding from A. So the velocity of approach would be this velocity minus this velocity. And if we have to make the velocity of approach to be 0, then that means that at this instant 20 cos alpha should be equal to 20 sin alpha, because then only the velocity of approach would be 0, and that would be the condition for the closest approach of the two trucks. This gives us tan alpha is equal to 1. So this alpha would be 45 degree. When alpha is 45 degree, then that is the instance at which the trucks are closest to each other. So if this is 45 degree, this is also 45 degree. Fine. Now if this is 45 degree, and let's consider this to be happening at time t. When this has happened at time t, then this distance would be 10 minus the speed is 20 into t, because 20 into t will be the distance traveled by B, and this is the distance traveled by A. This will also be equal to 20 into t. Now these two must be equal from this triangle. So what we have is 10 minus 20 into t should be equal to 20 into t. So t should be equal to 1 by 4. The unit is r. So time that it would take for the two trucks to be coming closest possible would be 15 minutes. And the closest possible distance, you put t here, you will get 5 and 5. The closest possible distance will be 5 root 2. Okay? So pretty simple. Fine. So now we are doing the last problem in this section, and this one you should really be able to pull off.